Hello. In this video, we're going to study distances, and in particular, we're going to start with the distance around a circle. So let's take a look at this circle here. We have a number 24 here. This is equal to the diameter. And so if we want, we could cut that in half, and the radius would be 12. Remember, the radius is the distance from the center to the outside. And that number can be used in a typical formula. The circumference, or the distance around a circle, is equal to 2 pi r. So the circumference here would be 2 pi times 12, so 24 pi. And then, of course, we'd want to put those centimeters. So that would be the distance, 24 pi centimeters. Or, of course, if you had a calculator, we could convert this into a decimal. So you do 24 times pi. This is sometimes called the exact value because the pi is still left unmultiplied. The precise value would be 75.398 centimeters. That'd be like the rounded answer or the decimal answer. And of course, in pre-cal here, we always go to 3 decimal places. 3 decimal places. All right, well, that was an easy warm-up. Let's make the question a little bit more complicated. What's the distance from A to B? So we have a similar circle because the radius is still 12. But now we're not going all the way around the circle. We're only going around 40 degrees. We're only going a portion of the circle. How would we figure out the distance here? Well, I'd encourage you to pause the video and give it a try. Either use some logic, maybe look at the formula sheet, see what you come up with. All right, so assuming you gave that a try, you might see this formula on your formula sheet. S equals theta r. Now that looks pretty similar to the 2 pi r, and indeed it's based on that. This will give us this distance s. So we go ahead and take our theta, 40 degrees, times by 12, and that gives us 480 centimeters. Wait a minute. If this is 12, I mean, if I was going to eyeball this, I would say this is like a little bit less than 12, maybe like 10 or something. I don't think that's going to be 480. Yeah, no, something seems wrong here. Let's think about this a little bit. Well, the formula says theta r, but we've been learning about radians. And so this is the correct formula, but the theta here needs to be measured in rad. The formula only works if we're using radian measures. So 40 degrees over 360 is equal to x over 2 pi. And so we can solve then to get 80 pi over 360, which is 8 over 36 pi, which will be 2 over 9 pi. So this number here, 2 pi over 9, is the theta that we want to use because we want to use a radian theta, not a degree theta. R will still be 40, R will still be 12. So we multiply that and we get 24 pi over 9. Then we can simplify that because they're both divisible by 3. So we'll get 8 pi over 3 centimeters. Now if we convert that into a decimal, that's going to give us 8.378. Just again for your rounding skills, right? This will be 7, 5, 8, and so on. We want to go to 3 decimal places. So we look at the 5 and the 5 rounds up. So it'll be 8.378 centimeters if you wrote it as a decimal. And now that seems more reasonable. This seems less than 12. Around 8? Yeah, that seems all right. So this formula works now, and we need to know, of course, that the theta needs to be in radians. That was the key to get the formula to work. But some of you might still say, well, Mr. Peters, why do we have an S over here? I mean, if we're talking about the distance, why isn't this like D? Why is it S? It seems confusing to label distance with a letter like S. S stands for like, I don't know, maybe space, or S stands for seconds. Well, why would S stand for the distance? And it's actually a really interesting kind of history. S comes from the Latin word spatium. Spatium. I'm not sure if I'm pronouncing that right, but that's a Latin word. And so the initial discoverers and namers of this formula, they really liked Latin. Maybe they spoke Latin. And so they decided to use an S because in Latin, distance or this arc length, because what you can call this is sometimes called an arc length. It's a section of a circle, like an arc, like a portion of it. And so this arc length around the circle is a distance, it's an arc, it's a length. And in Latin, the word that's used for that is spatium. So then they give it an S. And this actually comes up a few different times in math. If you think about the integers, right, -2, -1, 0, 1, 2, 3, and so on. Okay, the proper label for this set is a capital Z. Now, I mean, the real numbers, that makes sense. You use an R for the real numbers. But why would you use a Z for the integers? Why not use an I for the integers? Well, again, that's because the Germans were the ones who labeled integers. And in German, the word for integer or number is Zahlen. Zahlen in German. Not sure if I'm pronouncing that right, but doing my best. And so the Germans labeled the integers, so the Germans used the word that made sense to them. Even something like y equals mx plus b, you might wonder, why would we use m for slope? I mean, this is slope. Doesn't slope start with an S? Maybe the S should be used over here. But I did some research, and some people think that this is actually from the French word montre, which means to climb. Now that one's a little bit less certain, but what we have here are some really interesting examples of the multicultural aspect of math. Here, this is arc length, but it comes from the Latin word spatium. Here, these are integers, but it comes from the German word Zahlen. And here we have m for slope, which comes from the French word montre. Again, it's just interesting to see these connections. I know it's tricky for students because you wish all of the labels were the words that we use in English. But I think it's kind of beautiful to see the different portions of math that come from different cultures and languages. And so while it might be a little tricky to remember that S stands for arc length, the section around a circle, just remember that it's a nice reminder that some mathematicians were using Latin at the time. And I find that interesting and encouraging. So let's go ahead and use this technique. How do we find the arc length? Well, we use the formula S equals theta r. We ensure theta is in radians. We make sure we put units at the end. So let's say the diameter was 36 centimeters and theta was 60. Go ahead and pause the video and give this a try. All right, so first we get the radius, which means we have to divide it by 2. Then we have to convert this into radians. This is a number you might know already. 60 degrees is just pi over 3. It's one of the common ones. As you get more and more used to these 30, 60, 90, 45, you'll get used to converting these ones really quickly. So then S equals 18 times pi over 3, which would be 6 pi centimeters. Now, if you wanted to convert it into like a decimal number, you can press the SD button on your calculator. So again, if you've been having trouble with this, there's a little button that looks like SD. It will convert from exact values into decimal values. So that'd be 18.8495. So we round that to 18.850 centimeters. Okay, let's do a little bit of an advanced question. Let's find the perimeter of Pac-Man. So here we have the classic Pac-Man from one of the original video games. We're told that the radius is 5 centimeters, and you need to determine the perimeter. So go ahead and pause the video and give that a try. All right, so this is 5, and this is 5. Those are the 5 centimeter radius. But we need to figure out this angle theta. Well, if this angle is 90 degrees, then the other angle, because they both add up to 360, must be 270. Now we need that theta in radians, so that'll be 3 pi over 2. Radius is 5, so S equals 3 pi over 2 times 5. That's going to give us 15 pi over 2. But remember, that's just going to be the arc length. That's the arc, the section around the circle here. We still need the mouth of Pac-Man. And these are both straight lines with a length of 5 each. So the total distance around Pac-Man is 15 pi over 2 plus 10 centimeters. Or, if you wanted it as a decimal, 33.562 centimeters. Okay, one more question here. In the diagram, each of the 3 identical circles touch the other 2. The circumference of each circle is 36 centimeters. What is the perimeter of the shaded region? So the shaded region is right here, and we're looking for this perimeter around. If you want me to highlight it here, we can kind of see it's like this, and then this, and then this. Go ahead and pause the video and give it a try. All right, this question is kind of funky. What you need to do is look at the 3 centers of the 3 circles, and then draw yourself a triangle. Well, because this triangle, each one of these is a radius, all of the sides of the triangle are the same. So this is called an equilateral triangle. And if all of the sides of a triangle are the same, therefore all of the angles are the same. So theta equals 60, because to have 3 equal angles in 180, right, 180 divided by 3 equal angles gives you 60. So theta is 60, or in radians, we would say theta is pi over 3. Now each one of these blue sections is an S, right? That's going to be an arc length. S equals theta r. Well, we know theta. Can we work back and find r? We can, because if we know the circumference is 36 centimeters, that means 36 equals 2 pi r, because circumference is always equal to 2 pi r. And so if we know the circumference, we can work back and find r. That will give us r equals 36 over 2 pi, or 18 over pi. So we plug that in for our r, 18 over pi. We plug this in for our theta, pi over 3. And so s equals, well, the pi's cancel, and s just equals 6. Now there's going to be 3 of them, right? There's 3 little s's here, 1 s there, 1 here, and 1 here. So the final perimeter is equal to 6 plus 6 plus 6, or a total of 18 centimeters. Don't forget the units. And this is a really nice question because we get a nice whole number answer in the end. And if you didn't do this properly, if you just worked through it and you said, oh, 18 over pi, and you converted that into a decimal, right, that's going to give you 5.730. And if you turned this here into an s, we'd have s equals 5.730 times pi over 3. Well, 5.730 times pi over 3 is going to give us, let's see here, some number, 6.00044. And then being the good student that you are, you keep that number on your calculator and you multiply it by 3, because there's 3 sides, making sure not to round too early, and now you get 18.001 centimeters. But the problem is we're now off by a single decimal point. And you might say, oh, well, I could have saved it if I would have rounded here. But this is just sketchy. Rounding here or rounding here, it's not going to work. We don't ever want to round any value until the final number. So if you're going to do this, and instead of writing 18 over pi, put it as a decimal, you need to include all of the decimal points. And over here, you need to include all the decimal points, because otherwise rounding early is going to introduce small errors. And unfortunately, you might end up with a number slightly too big or slightly too small. And you will lose a half mark for rounding too early. All right, so let's go ahead and take some notes. We studied arc length. That was our topic for today. The formula is S equals theta r. S is going to be, just as a little diagram here, we've got our circle. Oh, here's our circle. And this section here, this is our S. Now, theta is going to be this angle in here. And then R is going to be this length here. Now, theta always has to be in rad. And R, we're going to want to keep our units. Keep the units for the end. But otherwise, it's a pretty straightforward formula. Nothing too crazy to go wrong here. So let's do a quick example. Let's say R is 7 meters. Theta is 90 degrees. Determine S. So go ahead and pause the video and give that a try. All right, well, theta will be pi over 2. So S equals theta R. S equals pi over 2 times 7. So 7 pi over 2 meters. And again, I really like leaving it as an exact value. I'm not a huge fan of turning it into a decimal, but if you absolutely must, this is 10.996 meters. For some extra practice, you can look on worksheet 4 and 4.5. And then you can write down any things to remember. The most important thing I would say is units. But of course, you might also want to write down, don't round until the end. We'll probably talk about this more in future videos, but we need to be careful with rounding. Whenever you're doing rounding with your calculator, you always wait until the very final answer, the one you're going to box. That's the only one you round. Everything earlier, you want to keep all the decimals. You want to use that ANDS button on your calculator to pull the previous answer. You really want to use as much precision as possible because you don't want to end up with some kind of rounding error. All right, hopefully you enjoyed this video, and as always, thanks for watching.